All right, we are going to practice some monomial operations. To help you review some of the things that we've done so far. So, I would encourage you to work through these with me. I am going to start with number 1. So, first thing I want you to always do is identify what operation you're dealing with, because it's going to be all mixed together from here on out. So you have to identify what you're actually doing. And in number 1, in this problem, we are adding two monomials. So the first monomial is here, and the second monomial is here. The addition tells us what we're doing. So I'm going to go ahead and work through that problem. Remember my rule. When I am adding or subtracting monomials, I must have you must have like terms. And then we can combine like terms. Like terms have the same variables raised to the same powers. So our terms that are alike are a to the 4th, b to the 9th. And now we're going to deal with the coefficients. Remember, those are the numbers in front of the terms. So in front of the variables with the exponents. And make sure you circle the sign with the number. So we have negative 11 plus 6. Did you get that one? Negative 5, right? Negative 5. Okay, in this problem, number 2, we are once again adding. So we're going to, in our minds, go back to the rule that we have. We must have like terms, k and k. And then another one we have is k squared and k squared. So I'm going to bring down k squared, and I'm going to bring down k. All right, so let's first deal with k squared. So I have a negative 3, and I have a positive 5. Negative 3 plus 5 is a positive 2. Now let's deal with the coefficients of k. Remember, when there's just a negative or nothing at all, that indicates a 1. Okay, so I have a negative 1 plus negative 8, or negative 1 minus 8. And that would be negative 9. So make sure you're bringing that sign along with it. So let's go to number 3. And in number 3, we have the words written out. So we're subtracting. Therefore, we know we're going to have like terms. Our like terms are m. So let's bring that down. Be careful here. This is a turnaround. We're going to subtract this from this. Subtract this from this. Now remember, subtraction is not commutative. In other words, I can't switch it around and get the same thing. So I have to do it in the correct order. So negative, you know what, that is kind of in our way. I'm going to get rid of it. Negative 7m minus 2m. And in this case, we're going to have m as our like term, and then negative 7 plus negative 2, or negative 7 minus 2 is negative 9. Okay, we're going to switch it up a little bit, and we are now going to not be adding. In this case, we are multiplying. So look for the sign first. Figure out the operation. All these 4, 5, and 6 are multiplying. So we have a common base. That is x. And our exponents, when we're multiplying, remember the rule is we add the exponents and we bring it on down. 8 plus 3 is 11. Okay? So then here we have multiplication we've identified. We've identified the common base. And our first step, if there are coefficients, is to multiply those. So 15 times 3, 15, 30, 45, and one of them is negative. So we have a negative 45. K is the common base. Now we add the exponents. 3 plus negative 10, negative 7. Now remember, in our in our instructions, it says express final answers using only positive exponents. So you'll remember how we have to deal with this. This is the same as negative 45. He's going to stay in the numerator. And anything that's raised to a negative power is going to drop to the denominator and become positive. Okay, so let's try the next one. For this one, we're multiplying. We've identified the operation. We do have coefficients, so we're going to deal with those first. Negative 9 times negative 2 is a positive 18. R has no power, but we know that that's really a 1. So we're going to bring down the R and the S, and we're going to add the exponents. R has 1 plus negative 5 is a negative 4. And S has 2 plus 12, which is 14. Now we're going to take our shortcut. 18 is going to live in the numerator, and I'm going to draw my vinculum. The other thing that's going to stay in the numerator, which has a positive exponent, is S to the 14. Doesn't 18 have a positive exponent? It would be 1, correct? So R to the negative 4 goes to the denominator and becomes positive. All right, let's go here. In numbers 7, 8, and 9, we are dividing. Let's choose this blue. And when we're dividing monomials, we look for the common base, and then we subtract the numerator's power minus the denominator's power, and it must be in that order. 12 minus 3 is 9. Okay? Now, if there are coefficients like in number 8, and we're dividing monomials, we must first divide the numerators. We must first divide the coefficients. So 40 divided by a regular 5, 40 divided by a positive 5 is 8. 40 divided by a negative 5 would be a negative 8. P to the 8, P to the second. So we take 8 minus 2 is to the 6th. I can see that I'm going to end up with a negative power here. So I'm going to go ahead and throw it in the denominator. So we're going to end up with Q. It would have been Q to the 2 minus 3. What would that be? 2 minus 3, negative 1. So because we're going to plop it in the denominator, it's just going to be Q to the first power, or Q. Now, you'll notice here in number 9 we have coefficients, but these coefficients, they can't be divided like 40 divided by 5. 6 over 15 is a fraction, so we're going to maintain a fraction, but we're going to simplify it by dividing by a common factor of 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. So 6/15 is simplified to 2/5. Now we have C. Well, let's make sure we know where we're going to put it, bottom or top. Negative 1 minus 2. Negative 1 minus 2 is actually going to be in the denominator, isn't it? Negative 1 minus 2 is negative 3. We plop it in the denominator and make it positive. Now, D, let's figure out if it's going positive on the numerator or negative in the denominator. Negative 3 minus a negative 11. I'm going to write that out. Negative 3 minus a negative 11. So you'll notice, add the opposite, and we get negative 3 plus 11 is a positive what? 8. So we have a positive, so it's going to go in the numerator and put that with it. Okay, the last three are powers raised to powers is another way of saying that. And I'm going to choose a new color. Well, I don't know how well this will show up, but we'll give it a try. Remember, we look for the common base, or the base that we have here in this monomial raised to this power. And the shortcut is we take this in the power within the parentheses, and we multiply it times the power outside. So that would be x to the 30th. Okay, so we have a coefficient, so we must raise the coefficient to the power on the outside first. So 12 squared is 144. Negative 12 times negative 12 is also positive 144. A to the 2 times 2 is 4. B to the negative 6 times 2. Negative 6 times 2 is negative 12. So we have to rewrite this and put that in the denominator. So 144, a to the 4th. Then we put the negative in the denominator and make it positive. Okay, let's finish up with this one. We have a coefficient. We raise that to the negative 3 power. Well, in order to accomplish this, we're going to have to take this whole thing and put 1 over what we have to begin with. 1 over 3m to the 7n to the 6th raised to the positive 3 power. So let's continue. 1 over 3 to the 3rd power. 3 times 3 is 9, times 3 is 27. M to the 7 times 3, which is 21. And n to the 6 times 3, which is 18. Okay, that's a strange problem, but we managed to work it out. All right, I hope this is helpful to you as you review operations with monomials.